Hello. We are going to discuss the basic integration rules. First of all, we must know what an integral and integration are. An integral is the sum of an infinite number of rectangles under a curve. Below is an illustration of what is done when taking the integral. Integration is basically doing the opposite of what you would do to get a derivative. If you look at the example below, you have f of x is equal to x squared. The derivative of x squared is 2x. Now, if we were to take the integral of that, if we were to take the integral of 2x, we would have to add 1 to the exponent, giving us x squared, and then divide by that new exponent. So we'd have 2x squared over 2, which turns back into the original x squared. Let's begin with the constant rule. This rule is quite simple, and it only involves adding an x to the constant. This is done because if we use our power integration rule of adding 1 to the exponent, then dividing by that new exponent, we would take the x to the 0 and make it x to the first, then divide by 1, which would be the same as just adding an x. In our example, we have the integral of 5, which following our rule would be 5x. Next is our power rule, which I have already touched on when explaining the constant rule. The power rule involves taking the integral and adding 1 to its exponent, then dividing by the new exponent. In our example, we have the integral of x cubed. First, we add 1 to the exponent, so we now have x to the 4th. Then we must divide by that new exponent to get us a final product of 1/4 x to the 4th. The sum and difference formula involves simplifying the problem into separate integrands. In this example, our polynomial can be separated into 3 separate integral problems. We now have the integral of x squared plus the integral of 2x minus the integral of 5. From here, we use our constant and power rules to find the integrals separately, then combine them to get a final product of 1/3 x cubed plus x squared minus 5x. Our next rule is the e to a power rule. In order to get the integral of this, you must have the derivative of whatever is to the power of e in front of the e. For example, if we had 6e to the 6x, since the derivative of 6x is 6, and we already have a constant of 6 in front of the e, we can go ahead and follow our rule. The u prime is consumed and is left with e to the 6x. In more complicated problems, we would have to create the constant by multiplying a constant in front of the e, then putting the inverse of that constant outside of the integral. Our final rule is the Lin rule. This rule is like the e to the x rule in a sense that you must have u prime and it gets consumed in the integral. The rule is that if you have u prime over u, then the integral will become ln absolute value of u. In our example, we have 22 over 22x, which follows our rule perfectly. Since 22 is the derivative of 22x, we continue on with the rule in which 22 is consumed, and we are left with ln absolute value of 22x. That concludes our presentation. Thank you. I hope this helps. We're now done with basic integration rules.